Welcome to the deep dive. We've got a whole stack of stuff on software design this time, especially that Clean Architecture book by Robert C. Martin.
Oh, yeah, that's a good one.
So, ready to unpack this?
Absolutely. Let's dive in.
Today we're going deep on software design. And trust me, it's way more interesting than it might sound at first.
It really is, yeah. There's so much to it.
We're going to figure out why good design matters, how programming got to where it is today, and most importantly, how to structure software so it doesn't turn into a complete nightmare.
Right, because nobody wants to deal with that. One of the things that Robert C. Martin really emphasizes in his book is that software design and architecture, they're basically the same thing.
He does kind of hammer that point home, doesn't he?
Yeah, he really does. He's trying to clear up all the confusion around it,
Yeah.
and just give us a solid understanding of what good structure actually looks like.
And he uses a really good analogy to get that point across.
It's a building analogy.
Yeah, comparing software architecture to building architecture.
Right, because a building needs a strong foundation if it's going to last. And software is no different.
And if you think about it, both types of architects, they're kind of aiming for the same thing.
They are. They want to create something functional, of course, but also something that can adapt and change.
Exactly. And in the software world, that means making sure it doesn't take a massive team of programmers just to keep the system running, let alone make updates.
Yeah, you don't want to be drowning in code.
Yeah.
It's got to be manageable.
Right. A system that you can't change is basically useless at that point.
Totally. Yeah, it's like a dead end.
This reminds me of that article you sent me about the challenges of dealing with legacy code.
Oh, yeah.
That really highlighted how fast a system can become a burden if you don't design it with change in mind from the beginning.
Absolutely. And that's why it's so helpful to understand how programming has evolved over time. Think about how far we've come from, like, the days of Alan Turing.
Seriously, it's mind-blowing.
Those early programmers were literally writing instructions in binary code. Can you imagine?
I can't even wrap my head around it. Talk about a steep learning curve. But it's amazing to see how those early ideas evolved into what we have today. And speaking of evolution, we got to talk about Edsger Dijkstra and his impact on structured programming.
Oh, absolutely. Dijkstra was a game changer.
Big time. His famous letter, Go to Statement Considered Harmful, really shook things up in the programming world.
Yeah, considered harmful, more like considered downright dangerous in some circles.
Right.
But Dijkstra was onto something. He was pushing for this structured programming, with clear loops and conditional statements.
That's more organized.
Exactly. It's like he gave us the building blocks to create more reliable and understandable software.
This history of how we got to structured programming is so important. It shows us why ignoring architecture is like trying to build a house without a blueprint.
Yeah, you might get something up at first, but it's going to be a disaster waiting to happen.
And Robert C. Martin, he illustrates this point perfectly with the story of the hare and the tortoise. Remember that?
Oh, of course. The hare, focused on speed, loses to the tortoise, who takes a steady, planned approach. It's the same with software development.
Exactly. If you're just churning out features without a solid architectural foundation, you're going to hit a wall eventually.
Oh, you will. The technical debt piles up, and suddenly, even adding a simple feature becomes a nightmare.
Ugh, it's the worst feeling.
Been there, staring at that code base wondering, who wrote this?
It's like technical debt is whispering sweet nothings in your ear, tempting you to make things worse.
Exactly.
And that's exactly what happened on that project I was telling you about. It started so smoothly, but without a good architecture, adding new features became like jamming square pegs into round holes.
You can picture it now.
It's like that graph in the Clean Architecture book. You know,
Yeah.
the one that shows productivity just tanking as the code gets more and more tangled?
Yeah, it's a slippery slope. And that's where object-oriented programming comes in.
But it's become so fundamental to how we build things.
It really has.
And everyone always talks about combining data and functions.
Right. That's the textbook definition. But what really clicked for me about OOP is how it lets us model real-world things in code.
Like we're creating a little digital world.
Exactly. Instead of just having the scattered data, we can bundle it up with the actions that actually operate on it.
Makes it so much more organized.
Right. It's all about managing complexity, creating
Right.
these self-contained units that actually mirror real-world things.
And then you've got features like polymorphism.
Polymorphism.
Yeah.
It sounds intimidating, but it's actually pretty cool once you get it.
It always seemed a little bit scary to me, to be honest.
Think of it this way. You've got a power drill, right? And you can use all sorts of different tools with it, like a screwdriver bit, a drill bit, a sander attachment, and so on.
Right. Different tools, same drill.
Exactly. Each tool does something different, but they all fit that same connection point on the drill. Polymorphism is kind of like that. You can have different parts of your code respond to the same instructions, but they each do it in their own specific way.
Oh, okay. That makes much more sense.
It gives developers a lot more control over how different parts of the system work together.
So we've got modularity from OOP, and polymorphism gives us even more control over how things behave. This brings us to another crucial set of ideas, the solid principles.
Ah, yes, the solid principles. They're like the building codes for good object-oriented design.
Okay, I get the acronym SOLID, but honestly, I always get a little lost in all the details of each principle.
Yeah, there's a lot to unpack.
It's a lot to take in all at once.
Maybe some simple examples would help.
Yeah, that would be great.
Okay, so the first principle is the single responsibility principle, or SRP, if you like acronyms.
I do.
This one is all about focus. Each part of your code, like a function or a class, should only have one reason to change.
One reason to change. Got it.
Imagine you have a chef, but they're responsible for both cooking and cleaning. They wouldn't be able to focus properly on either task. It's the same with code.
So if I have a class that's doing both data validation and talking to the database, that's a violation of SRP.
Exactly. You'd want to separate those responsibilities into two different classes, each with its own laser focus.
Okay, breaking things down. Got it. So what's next in SOLID?
Next up is the open-closed principle, or OCP. This one's a little tricky to wrap your head around.
Okay, hit me with it.
It states that software entities should be open for extension, but closed for modification.
Wait, open and closed. How can something be both?
It's not about literally preventing any modifications. It's more about designing your code so you can add new functionality without messing with the existing code that's already working. Imagine you have a software module that calculates shipping costs.
Okay, yeah, I can picture that.
Now let's say you need to add a new shipping method. You shouldn't have to rewrite the entire calculation logic just to accommodate that.
Right, you'd want a way to just sort of plug in that new method without disrupting everything else.
Exactly. You're extending the functionality without modifying what's already there, and hopefully well tested.
Okay, starting to make sense. These solid principles sound like they can really help create more robust and maintainable software. What else is on the list?
Next, we've got the Liskov substitution principle, or LSP, but it's a bit more nuanced. We can dive into that one later when we talk about the specifics of clean architecture. For now, let's jump to the interface segregation principle, or ISP.
All right, lay the ISP on me.
The ISP is all about creating specialized interfaces instead of having one giant monolithic one. Imagine you have a module that can send notifications, email, SMS, push notifications, the whole works.
Okay, lots of ways to notify.
If you create this massive interface with methods for all those notification types, any class that uses that interface has to implement all those methods, even if it only needs to send emails.
That seems inefficient.
Right. So it's better to create separate, smaller interfaces, one for email, one for SMS, and so on.
Each class just worries about what it actually needs to do.
Exactly. This keeps your code more focused and prevents unnecessary dependencies. So that's the ISP, specialized interfaces for more modular code.
Got it. What's the last one in solid?
The last one is the dependency inversion principle, or DIP. This one's all about depending on abstractions, not on concrete implementations.
Abstractions, concretions. Things are getting a little abstract for me now.
Think of it like a lamp.
Okay, a lamp.
You plug it into an outlet, and it gets electricity, right? But the lamp doesn't care if that electricity is coming from a coal power plant, a hydroelectric dam, or a solar panel. It just needs the right voltage and current.
So it depends on the idea of electricity, not the specific source.
Exactly. And in software, we can create those kinds of abstractions using interfaces or abstract classes. It's how we decouple our code from specific implementations, making it much easier to change things up later without having to rewrite everything.
That's a really good analogy. So we've laid the groundwork, explored these key principles. I think we're ready for the main event, clean architecture.
Let's do it. Time to see how all these concepts come together to create those robust and adaptable software systems we keep talking about.
Sounds good to me.
So, ready to dive into the heart of clean architecture.
Let's do it.
It's all about creating a system that's like organized into these distinct layers.
Right, like those concentric circles we talked about before.
Exactly. Each layer with its own responsibilities.
Like a target, with the bullseye being the most important part.
That's a good way to think about it.
But how do these layers actually work in practice? How do they all fit together?
Okay, imagine a castle.
A castle.
Yeah, with all its different levels of defense.
Okay, I'm picturing it.
At the very center, you've got the most valuable treasure, the heart of the kingdom.
The crown jewels.
Exactly. That's your entities layer in clean architecture.
Okay, so the entities layer is where we define like the core data and logic that make our application unique.
Precisely. The entities encapsulate the essential business rules, the things that would be true even if you completely change the technology you're using.
So they don't care about databases or web frameworks or any of that stuff.
Nope, they're pure business logic.
Untouched by the messy details of implementation.
Exactly.
So in that e-commerce example we talked about before, the entities would be things like product, customer, order.
Yes, those are the fundamental building blocks of the business.
Got it.
And the key here is that these entities should be completely independent of any specific technology.
Okay. Pure business logic.
So we've got the entities at the core, the crown jewels.
What's the next layer out? What protects those crown jewels?
The next layer is where we define how those entities are used to actually, achieve specific goals within our application.
Okay, so it's not just the data, it's how we use that data.
Right. This is the use cases layer.
Use cases.
Think of use cases as the blueprints for the actions and processes that our system can perform.
So if our entities are the nouns of our system, the use cases are the verbs.
That's a perfect way to put it. So add item to shopping cart or process payment, those would be use cases in our e-commerce example.
Each use case is like a specific action the system can take.
Yes. Each one encapsulates a specific piece of business logic.
Okay, and these use cases, they're also independent of any specific technology, right?
Absolutely. They don't care if it's a web app, a mobile app, or even a desktop application.
Technology agnostic, just like the entities.
Precisely. Focusing solely on the business logic.
Like the generals directing the troops, but they don't care about the specific terrain of the battlefield.
Exactly.
Okay, so we've got our entities and use cases locked down in these inner layers.
Safe and sound.
But at some point, we need to connect all this to the outside world, right? Like, how do users actually interact with the system?
That's where the interface adapters come in.
Interface adapters.
They act as a bridge between those inner layers of pure business logic and the outer layers of technology-specific code.
Right, because the inner layers don't want to deal with all that messy stuff.
They shouldn't have to.
So the interface adapters handle the translation between the abstract world of entities and use cases and the concrete world of databases, user interfaces, and all that. It's like having a translator who can speak both the language of the business and the language of technology.
That's a great analogy.
So if a use case needs to save data to the database, it wouldn't write SQL queries directly, right?
No way. It would pass the data to an interface adapter.
And the interface adapter would handle all the nitty-gritty details of how to talk to the database.
Exactly. Keeps the use case nice and clean, focused on the business logic.
And the same goes for handling user input, right? Like when a user clicks a button on a website.
Absolutely. That event would get passed to an interface adapter, which would translate it into something the use cases can understand.
Okay, so the interface adapters are like the go-betweens.
Yeah, the mediators.
Making sure each layer speaks the right language and doesn't get confused by details from other layers.
It's all about clear communication.
Now, I remember you mentioned two main types of interface adapters, controllers and presenters.
You got it.
Remind me again what those do.
Controllers handle incoming requests.
Okay, like traffic cops.
Exactly. They direct the flow of information.
And presenters.
They handle outgoing data, formatting it in a way that makes sense for the user interface or any external system.
So controllers are like input handlers, taking requests from the outside world.
Right.
And presenters are like output formatters, presenting the data in a way that's understandable.
You nailed it. And both of them live in that interface adapters layer, keeping our core business logic nice and isolated.
Okay, so we've worked our way out from the core of the system through the use cases and now to the interface adapters.
We're getting there.
What's the final outermost layer?
The outermost layer is the frameworks and drivers layer.
This is where we get down to the nitty-gritty, right?
Exactly. This is where we deal with all the specific technologies and tools that our system depends on.
Like databases, web frameworks, UI libraries, all that jazz.
All that good stuff. This layer contains all the code that interacts with the outside world.
But it's important to remember that this layer shouldn't have any impact on those inner layers, right?
Absolutely not. The entities and use cases shouldn't even know this layer exists.
Like changing the engine in a car.
What do you mean?
The driver shouldn't have to learn a whole new way to drive just because the engine is different.
That's a great analogy. It illustrates the power of clean architecture perfectly.
Decoupling our core business logic from those specific technologies makes the whole system so much more adaptable.
And maintainable in the long run.
Tests. Okay, I think I'm starting to get the big picture here,
Good, good.
but I'm still a little fuzzy on how data actually moves through these layers.
Okay, what's tripping you up?
Well, we talked about controllers and presenters translating data between layers, but
Right.
are there like specific rules about how that should happen? Any guidelines?
That's a great question, and yes, there are. One of the key principles of clean architecture is that data should always be transformed into the most convenient format for the layer that's using it.
Okay, so if a use case needs to pass data to a presenter, it shouldn't just hand over a raw data object from the database.
Idiotic.
It should like package that data up in a way that makes sense for the presenter.
Exactly. It
Yeah.
might even involve creating separate data structures for each layer, even if they represent the same underlying concept.
So you might have a customer entity in the entities layer, but then you'd have a customer request object in the controllers layer, and maybe a customer view model in the presenters layer.
Precisely. Each one tailored to the specific needs of that layer.
It's like having different sets of blueprints for the same building.
What do you mean?
One for the architects, one for the engineers, and one for the construction workers.
Perfect analogy. And while it might seem like extra work up front, it really helps to prevent those unwanted dependencies from sneaking in.
Keeping everything nice and separated.
And that brings us to one of the key benefits of clean architecture: testability.
Ah, yes. Testability. We've got to make sure our code actually works.
And by isolating our business logic from all those technology-specific details, we make it so much easier to write automated tests for our code.
I see how that works.
We can test our entities and use cases without having to set up a whole database or web server.
We can just focus on the pure logic of our application.
Exactly. And that makes a world of difference when it comes to maintaining and evolving our system over time.
We can change things with confidence, knowing that our tests will catch any problems.
It's a safety net.
I'm really starting to see the value of clean architecture here.
It's a game changer.
But there's one thing I'm still wrestling with.
What's that?
Robert C. Martin's whole idea that the database is a detail.
Ah, yeah.
It just seems so counterintuitive.
I get it.
Databases are complex and critical. How can they be just a detail?
It's a statement that throws a lot of people off. But when you think about it in the context of clean architecture, it starts to make sense.
Help me make sense of it.
Remember, the core of our application, the entities and use cases, they shouldn't care about the specific mechanisms of data storage.
So it's like saying a chef's recipe shouldn't depend on whether they use a gas oven or an electric oven.
Exactly. The essential steps of the recipe, the mixing, the baking, the frosting, those should all remain the same.
Regardless of the oven.
Exactly. And the same goes for our software.
The business logic shouldn't be coupled to the specific database technology.
Precisely. But I know what you're thinking. Databases are more than just storage containers.
They are. They have their own schemas, query languages, optimization strategies, all that stuff.
Right. And that's where our trusty interface adapters come in handy again.
Okay, so how do we handle all that complexity if we're treating the database as just a detail?
Instead of writing SQL queries directly in our business logic, we define an interface,
An interface.
an abstract contract that specifies how our application will interact with the data.
So we're creating this layer of abstraction between our business logic and the database.
Exactly. And that gives us the freedom to swap out the database implementation without touching our core application.
So if we decide to move from a relational database to a NoSQL database, we only have to change the implementation of that interface.
Exactly. Our business logic remains blissfully unaware.
That's pretty cool. It's all about decoupling and flexibility. But didn't Robert C. Martin have a personal experience that really solidified this view on databases for him?
You're remembering correctly. He tells this great story in the book about a project where he fought tooth and nail against using a relational database.
Oh, yeah, I remember that.
He thought it was overkill,
So he was a database skeptic back then.
He was. But here's the twist. The company went ahead and used a relational database anyway,
Sure.
and Martin eventually admitted that they were right to do so.
Wait, he lost the argument and he thinks they made the right call.
It turns out their customers expected them to have a relational database.
Really? Why?
It was a checkbox requirement, even though the customer didn't really understand how they'd use it.
So it was a business decision, not a technical one.
Exactly. Sometimes those customer expectations override our elegant design principles.
It's a good reminder that we can't always live in our perfect little technical bubble.
We have to be pragmatic.
Okay, so we've explored the idea that the database is a detail.
It's a detail.
But Robert C. Martin takes it a step further and says that even the web is a detail.
And that one's even harder to swallow for some people.
It is. The web is practically synonymous with software these days.
I know, but try to see it from a clean architecture perspective.
Okay, how do I do that?
The web is essentially just another delivery mechanism for our software.
Another detail.
Exactly.
But the web is a complex beast. Protocols, technologies, best practices, it's a lot to handle.
It is, but we don't want to let all that complexity leak into our core business logic.
So we're abstracting away the specifics of the web, just like we did with the database.
Right. And guess what we use to do that?
Interface adapters.
You got it. We'd have interface adapters for handling HTTP requests, processing web forms, generating HTML responses, you name it.
So instead of our business logic talking directly to web frameworks or libraries, we have this buffer layer of interface adapters that deal with all the messy web stuff.
Exactly. Keeps our core logic nice and clean.
It's like building a house with interchangeable doors and windows.
I like that analogy.
You can change the style of the doors and windows without messing up the structural integrity of the house.
And that's exactly what clean architecture allows us to do. We can swap out different web frameworks or even move away from the web entirely without having to rewrite our core business logic.
That's amazing.
It's all about adaptability and resilience.
Okay, so clean architecture is all about creating these adaptable, resilient systems that can evolve with changing technologies.
And changing business needs.
Right. Recognizing that all these details, the database, the web, all that stuff, they shouldn't be dictating how our application is structured.
They shouldn't pollute our precious core business logic.
Okay, it's all starting to click for me now.
Good. I'm glad to hear it.
But now I'm curious, how does Robert C. Martin suggest we choose the right technologies for our system in the first place?
That's a great question. He's a big advocate for what he calls boring technology.
Boring technology? What does that even mean?
Don't let the word fool you.
Okay.
He doesn't mean the technology itself is boring.
So what does he mean?
It means choosing technologies that are well established, well documented, and have a proven track record.
So we're going for reliability and stability over novelty and hype?
Exactly. Think of it like choosing a dependable car over a flashy sports car.
Okay, I get it.
And boring technology often has another advantage. It's usually easier to find developers who are familiar with it.
That's a good point. You don't want to be stuck with some obscure technology that only a handful of people in the world understand.
Exactly. That can become a real bottleneck.
So choosing boring technology can actually reduce risk in the long run
It can.
and make your system easier to maintain.
Absolutely.
But even though he's all about stability, Robert C. Martin also warns us about getting too cozy with frameworks.
Oh, yeah. He's not a fan of getting too tightly coupled to frameworks.
I can see why.
Frameworks are essentially someone else's architecture, right?
Right.
So when we embrace a framework, we're also embracing their design decisions.
Whether we agree with them or not.
Exactly. And he points out that the architecture of a framework is often not very clean.
Frameworks can be messy.
They tend to violate the dependency rule.
The one about dependencies always pointing inward.
That's the one. Frameworks often want you to inherit their code into your business objects.
Our precious entities.
Exactly. And that creates this tight coupling that can be really hard to escape.
So we need to be careful about how deeply we integrate frameworks into our system.
We do. We don't want to paint ourselves into a corner.
And what does Robert C. Martin suggest we do instead?
He suggests that we treat frameworks as plugins.
Plugins. We're back to plugins.
You got it.
But how do we apply that to something as big as a framework?
It's about creating an abstraction layer between our application and the framework.
Okay, so we're not calling the framework directly?
Nope. We define an interface that represents the functionality we need from the framework.
And that interface acts as a sort of middleman.
Exactly. It's a layer of indirection.
So we can swap out the framework implementation without affecting our core logic. Precisely.
That gives us a lot of freedom.
It does. We can experiment with different frameworks, choose the best one for our needs, and adapt to changing technologies without having to rewrite everything.
That's powerful stuff.
It is, and it highlights the core idea of clean architecture, creating systems that are adaptable, resilient, and able to evolve.
It's about recognizing that these details, whether it's a database, a web framework, or whatever,
They shouldn't be calling the shots.
they shouldn't be dictating the structure of our application.
Or polluting our core business logic.
Okay, this has been a really helpful breakdown.
I'm glad you're finding it useful.
I'm starting to see the light.
Good, good. So any other questions?
Yeah, I do have one more.
What's that?
You mentioned earlier that Robert C. Martin has some pretty strong opinions about how a clean architecture should reflect the business domain.
Oh yeah, he's got some great insights on that.
What exactly did you mean by that?
Yeah, he really believes in that idea.
So tell me more about that. What does he actually mean? It's all about making sure that the structure of your code, the names of your modules, the functions, all of that should reflect the core business logic. It should be clear what the system does just from looking at the code.
So you're saying if I open up the code for a system built with clean architecture, I should be able to tell what it does, even without reading any documentation.
Ideally, yes. He uses this great analogy in the book. Imagine you walk into a bakery. You see ovens, flour, dough, people wearing aprons. Do you need someone to tell you you're in a bakery?
I mean, not really. It's kind of obvious.
Exactly. It's self-explanatory.
Yeah.
And a well-designed software system should be the same way. The structure of the code, it should reflect the language and processes of the business it's supporting.
So it's like the code itself is speaking the language of the business.
You got it. So if you see modules named, like inventory management, order processing, or customer relationship management, you immediately get a sense of what those parts of the system are doing.
Even if you're not a programmer, you can look at the code and kind of understand what's going on.
That's the goal. And this focus on what's called domain-driven design, it not only makes the system easier to understand, but it also makes it way easier to maintain and evolve.
Because everyone's on the same page. Developers, business analysts, stakeholders, they can all speak the same language.
Exactly. It breaks down those barriers between the tech team and everyone else.
So clean architecture, it's not just about making the code work. It's about building a system that's in sync with the business, a system that can adapt as the business changes.
You nailed it. It's about building software that's not just technically sound, but also strategically aligned with the goals of the business.
This has been such a great deep dive. I think we've covered the essential elements of clean architecture and how it can help us all build better software.
It's a powerful approach for sure.
But I want to leave everyone listening with one final thought. Think about how these principles can be applied beyond software.
Ooh, that's interesting.
Could your business, your team, or even your personal life benefit from a clean architecture